Good afternoon, everyone, and welcome to the IMechE Tech Talk on Asset Integrity and Inspection Assurance, Innovation and Industry Challenges. We've got an excellent speaker lineup this afternoon. So my name's Alan D'Ambrosio. I'm the Market Development Manager in AB Consulting Services, and I chair the IMechE TSAC Committee, as well as sit on the Process Industries Board of the IMechE. So you'll have my company this afternoon, and in a couple of slides I'll take you through who our speakers are, but I've got just one slide of introduction and some administration, and then we'll move on to the speakers. Okay, so I've just put 4 pictures in there to look at, what the challenges are for the last 12 months in the pandemic on asset integrity. And each of the speakers are focusing on the changes in asset integrity and also the impact of the pandemic and maybe some of the new technologies in there. But if you look at those 4 pictures, the top one, top left-hand side, is LG Polymers in India, and they had a styrene gas leak. 12 people killed about a year ago now. They were starting up after being shut down due to COVID, and they were starting up a gas leak in there. And obviously, a gas leak in India is very, very sensitive after the Bhopal incident many years ago. The one on the right-hand side is actually nearer to home. So this is Wessex Water, an explosion in December 2020. 4 people dead in there as they were working on a sludge tank. The one below is a refinery in Indonesia. Explosion on storage tanks. It's destroyed 4 large oil storage tanks, as you can see on there. Fortunately, no one killed in that one. So that's the saving grace in there. And the bottom one, totally away from the process industries, is the incident in the last week in Italy, which is a cable car that actually crashed to the ground, and unfortunately 14 people killed. So, all of these happened in the last 12 months during the challenges we've had with the pandemic in there. So hopefully you'll hear from each of the speakers some of the challenges we've got around asset integrity, but also some of the novel ways we can get around those challenges as well. Just some administration in there. So all delegates are on mute. We will pose questions at the end to the speakers. So if you've got a question, please put it into the questions and answer box in there. And the event is being recorded. Hope that's okay with everyone. Sorry, wrong way. Okay, so the 3 speakers we've got, we'll start with John Wintle. John is a consultant engineer with TWI, and he'll take us through the changing balance of risks from aging and COVID-19 deferments on asset integrity. Then he'll hand across to Dave Burgess. Dave's a principal consultant in ABB, and Dave is a bit more technical. Will take us through the non-invasive inspection and give us some around the approach, the guidance and technologies available around NII. And finally, we have David Glass from the UK HSC, and David will just give us some of what the HSC's seen over the last 12 months, some of the insights the HSC's seen through deferments, through the application of RBI and NII in the process industries. So all of them fit in very, very well. So with that, I'll move on to the next slide, and I'll hand across to John. So delighted John's able to speak today. John's an independent consultant, formerly with TWI and the Weldon Institute, and a visiting professor at the Department of Mechanical Engineering at the University of Strathclyde. Active in pressure systems throughout his career, and he served on the IMechE's pressure systems group, as well as being chair of that group. Previous chair. Work focuses on providing advice and guidance to the industry. Over to yourself, John.
Well, thank you very much, Alan, for that introduction, and welcome everybody to this IMechE Tech Talk. I can't see you, and you can't see me, so I'm just trusting that that you're all out there waiting to hear what I've got to say. Of course, this has been a very challenging time during this pandemic, and even if those incidents are unrelated to the pandemic, once the investigations are known. I think it has to be said that there's been a lot of stress and difficulties within society and within industry. Companies have been reducing their manpower on site. There have been all sorts of restrictions, and I think people's general stress levels have risen during this period. So it's perhaps not surprising that there are incidents, and but clearly any incident is unacceptable. Right, now I better go back to my first slide. Yes, I'm going to talk about asset integrity and the changing balance of risks during this period of the pandemic. I'm going to start off by talking a little bit about aging and then a bit about risk-based inspection. I think topics that we'll all be familiar with. I'm then going to move on to some of the issues that have been raised by the pandemic, and then talk about the balance between doing invasive and non-invasive inspection. Invasive where equipment is opened up to be looked at from the inside, and non-invasive where it is not opened up and the inspection is done from the outside. And then I've got a few remarks in conclusion. During the presentation, there will be a poll question, which I'd like to invite you to answer. And Emma, who is there somewhere, will be putting up the poll question in the attendees chat area. But I will read it out when we get to that point. So aging, I think you could say aging was discovered in 2006. Of course it wasn't, but in 2006, we, that's my colleagues at TWI, but also involving Neil Henry at ABB and Glyn Amphlett representing SAFED, published HSE research report 509, Plant Aging, Management of Equipment Containing Hazardous Substances and Pressure, and it's become rather a bestseller. And this particular line from it has been widely shown, and I think it somehow captures the essence of aging. It's not how old something is, it's about its condition, and also how that condition is changing with time. There's a dynamic element in it, as well as where you are at this moment. And when we talk about aging, it's really relating to the condition of the equipment and any damage, degradation, defects that it may have sustained. So this graph here is the bathtub curve, except I've plotted it as in a cumulative way. And one of the things that 509 introduced was this way of looking at plant life in 4 stages. It divides aging into 4 stages, and of course stage 1 is when equipment has just entered service, and where there can be some early operational issues, design and manufacturing faults, commissioning faults, first startup kind of issues where maybe flanges are leaking, maybe things are haven't quite been optimized. But after a while, these things are corrected, and there's then a fairly long stage of what we call maturity, where the equipment is behaving as it's expected. There's minimal amounts of degradation. It has high reliability and availability. And during this time, any inspections that are done are largely confirmatory of the design assumptions, and there can be quite long intervals between them. And by stage 3, and I'm not going to, there's no scale on this, on the life scale. I don't know when the stage 3 kicks in. It's something that will be particular to each piece of equipment and plant. But we start to see in any situation, aging issues start to accelerate, just not both the number and the severity of them. And I'm having my ensuite refitted at the moment, and it's after 20 years, and it's amazing when we've taken it apart what there is to find. You really don't want to know about it. And so at this stage, there needs to be rather more emphasis on inspection and actually measuring and quantifying how much degradation has taken place. So there's quite a rapid change there. And then the final stage is where these issues become critical. The leak at the bottom of between my shower tray and the tiles became unacceptable, and I was forced to do something. I couldn't patch it up anymore, and in the end, it needed a completely new refit. So that was an example of the issues over life. We know what the risks are from aging. I don't really need to go through this in any great detail. There's loss of performance, unsafe conditions and environment, inability to comply with safety and other regulations, reduced margins, and unavailability of safety systems. And at worst, we've seen the kind of incidents that we saw at the beginning. So there are obviously risks and consequences from aging in relation to the performance, the safety, the resilience of the plant to be able to tolerate other events and excursions and dangers from leaks and pollution and worse. So what's to be done? Well, risk-based inspection. I recall that this has been around for over 30 years now, so for most of my career, and I've given a definition there: the planning of inspection frequency, coverage, method, and qualification relating to how it is applied, based on a risk analysis of likelihood and consequences of foreseen threats to integrity. It's a fairly general definition, but the key aspect words there are the risk analysis and the foreseen threats. And of course, you do your very best in a risk analysis to see all the possibilities, but no matter how good you are, there are always events and things that happen that are off your radar, and and I don't think we shouldn't forget that the incredible often happens, or occasionally happens, perhaps not often. Now, because the practice has evolved over 30 years following the Health and Safety at Work Act, the Persistent Safety Regulations, they came in 1989, I think, COMA and other regulations, and this shifted the responsibility very much onto the shoulders of the duty holders and the competent persons that support them, and it enabled the duty holders to change from time-based inspections to a more informed, data-driven process. And I remember the first event that IMechE held on this topic. It was in 1992, and it was called extending the intervals between inspections for process plant, or words to that effect. And that was it. That was in 1992 at HQ. I seem to remember that the main lecture theatre was full, and it really. And since then, I think we could say a lot is history. So that was risk-based inspection. Now, risk-based inspection has both benefits and limitations. On the plus side, I think everybody would agree that the greater analysis, the risk analysis, has enabled run times to be extended, and particularly in the early and mid stages, those stage 1, stage 2, particularly stage 2 of equipment life. And this has given greater confidence in the plant condition and rate of aging. There's been increased understanding about the degradation mechanisms, and a reduction, and with that, a reduction in the need to open and enter vessels for invasive inspections. There's what's called clean, non-corrosive service, which which, when it can be justified, enables a non-invasive approach. But there are also some negatives from it, and I think we should bear these in mind as well. It's expensive to set up, and it's quite manpower intensive. It's highly dependent on the amount of information that you know about the process conditions, the product, the operating cycles. There's a high reliance on that risk analysis and the data and the reliability of that data. And of course, it may not detect mechanisms that were not for conditions that were not foreseen. It's entirely reliant on the knowledge that you and the insight that you have available. Now, the pandemic has made undertaking plant inspections and maintenance much more difficult. Again, an unprecedented situation, something that any risk analysis would not have thrown up. How many of you in your risk-based inspections analysis considered the possibility of pandemic on your site? I bet not one of you. However, the impact of this has been that many scheduled inspections have been deferred, and to reduce, companies have wanted to reduce the number of personnel working on site. Travel and site access been restricted to essential need. I know that at TWI, there were very, very few people actually present on site, and we're all working from home. And then concerns about the risks to operators from invasive inspection. That being inside a tank or a vessel is a very confined atmosphere, and I think this is, and it's been felt that this is undesirable during this time of pandemic, and it's accelerated the trend towards non-invasive inspection. You've got to ask yourself, well, what are the advantages? Why change from invasive inspections? What's wrong with them? There's quite a few advantages. They prefer opening equipment. You can get in there and you can actually see what's going on. Direct visual access. Inspection methods. You can use apply magnetic particle testing to search for cracks, which you can't do from the outside, internal cracks that is, and it allows the really accurate locating of where there may be defects or damage on the inside surface, because you can you're actually there. And I think that there's no doubt about it, when you can see things directly, it does reduce uncertainty about those unforeseen damage mechanisms. Now, there are some disadvantages from invasive inspections. certainly they're expensive when you undertake them. They're expensive to prepare, and you have to take your plant down and empty it. There's confined space hazards. It's difficult and not nice work for operators. And opening vessels, particularly in systems which are normally inert, having clean, non-corrosive products can introduce air, water, contaminants, other things into those systems, which themselves can lead to problems. And of course, having open vessels, it can be difficult to seal them effectively after opening, because, for example, a manway may have bolts, and those, although you may, just the mere act of opening it may make it more difficult to seal, even though you might use new bolts. There's some distortion may well have taken place during service, which might make it more difficult to seal. So there are some significant disadvantages, and the increase in downtime and the confined space hazards are the first three are really the key ones. Now, in 2009, I was asked by the HSE, Pauline Hughes, to prepare a report on internal examination. Companies that were operating equipment with clean, non-corrosive service were claiming very long inspection intervals between opening them up, and the HSE said, well, was this all right? And the result of this was HSE Research Report 729, and you can still get it on the HSE website. It was based on practice and interviews with leading companies, and I can say we visited 2 ethylene manufacturers, 1 pharmaceuticals manufacturer. We also visited three refineries. We also talked to competent person organisations, IMechE, and the HSE themselves to get their views. And this report examines when intervals between internal examinations, that's invasive examinations, can be extended for vessels. And the key words there are clean, non-corrosive products. And within it, there's a process for establishing when non-invasive inspections can be justified and when internal examinations may be required. I threw this one in because it's always helpful to remind ourselves when we open a vessel or when we're thinking of doing our risk-based inspection, what are the main causes of internal defects and damage that you really want to have in mind. And I guess the first one is internal corrosion, whether it's wall thinning or pits. It could be hydrogen damage as a result of corrosion. May all depend on the combination of the product with the vessel or the tank material or any lining. It can result from level changes, and it may be not the product, but some contaminants within the product, or ingress of water or oxygen, or mixture of both, or space above the product that causes this. Breakdown of protective coatings. Many vessels are internally lined, and that is which are a key aspect of their integrity. Internal fixtures and things might have become loose as a result of vibration, and I've met situations where fluid impingements from jets coming into vessels through nozzles and have resulted in wall thinning on the far wall, where the fluid hits the wall and erodes the material. Fatigue cracking from the roots of seam welds. Internal welded attachments are a big site for fatigue cracks. Nozzle crotch corners are also key for those vessels in significant cyclic service, which you might wish And finally, I've put in thermal shocks, thermal cycling. We all know what happens if you put cold water into a hot basin or a hot teacup, cracking, creating thermal fatigue. Next slide, please. So the report asks the user to think about these questions in order to justify extending intervals between invasive inspections or reverting to non-invasive inspection. First of all, is there strong evidence? Use this phrase, strong evidence, to demonstrate no active internal degradation, particularly for vessels that are holding clean and non-corrosive products. And I think that the whole thing turns around the extent of the evidence that can be put forward from technical knowledge and other things. Does the inspection provide an equal level, a non-invasive inspection provide an equal level of confidence to that which is invasive? Would it be disproportionate to open the vessel and enter it under a lark? How well are the process conditions known and controlled? And do you actually know what is inside your vessel at all times? And to think finally, what are the consequences if an unforeseen internal degradation mechanism goes undetected? So those are the 5 questions that the sort of challenge questions that we recommended users should ask themselves. So what is good evidence? Well, first of all, evidence from the original design, manufacturing, the fabrication. What was the class of the original vessel? Has there been any damage detected in any previous examinations? Maybe you've done some remote visual examinations using endoscopes, vessels in equivalent service that have been examined after removal. Technical analysis, understanding of the chemistry and the elimination of corrosion, the elimination of fatigue, of significant fatigue. Having controlled and stable operating conditions, monitoring of cycles, is there enough sufficient to be confident as to what the process conditions are, the temperatures and so on? And finally, lots of things go wrong when there is change, and I think a robust management of change policy and procedure is also probably a requisite for moving away from internal examinations. So this is the kind of evidence that the report recommends. There will, of course, though, be times when in some invasive or when it will be necessary to open equipment up, when you haven't got sufficient evidence, when it's weak or there is significant uncertainty from non-invasive methods, particularly if there is some sort of indication from the outside surface of something going on the inside, where there's been a significant modification or an excursion outside, or perhaps a pressure excursion outside the original specified design pressure or process conditions. Maybe something's got into the process fluid. Of course, vessels are opened up for other reasons, to change catalysts, new linings and things. And on these occasions, it's appropriate to actually go and have a look, do some internal inspection. And finally, there's a category of vessels, particularly in the nuclear industry, where the consequences of failure are so high that the very low probability of unseen threats becomes relevant. And I think that you will find in the nuclear industry, there is, certainly amongst the nuclear regulators, there is a fair bit of resistance against relying entirely on non-invasive inspections. So I'm going to finish in a moment. Next slide, please, Emma. So this pandemic, I think it's been a challenge, but it's also, I feel, an opportunity. It's an opportunity for many for making changes to the way we do things that will ultimately be beneficial, and any moves towards non-invasive inspections and to replace invasive ones, providing they can be justified in the way I've just described, could well be a benefit that we can take with us into the future. But there are a number of questions that I'm looking to David Burgess, who's speaking after me, to try and answer. How can non-invasive inspections provide an equal level of confidence, particularly if they're used repeatedly and over the longer term? Do we have enough confidence in the methods that are available, and how are these what new methods are coming online, so I think the answer is technology. How can more sophisticated online plant data about the conditions and the loading cycles be obtained, and how would these be used for inspection planning? And finally, this is an area of huge or big data, and there is and the sifting and the use of that data, I think, is still at a fairly early stage, and I'm sure that data analytics and AI will be used more effectively. But one has also always got to bear in mind that if one's making decisions based on these kinds of techniques, that the source data is reliable, robust, and secure. So next slide, please. And I've reached my conclusion. With this introduction, I'd like to say that RBI is routinely used now for managing the risks from aging, but the pandemic is prompting companies to defer internal examinations. I think we'll come back to that. That's my reading of the tea leaves, but we'll come back to the poll in a moment. The trend towards extending run lengths is between internal examinations and using non-invasive inspection. It needs to be backed by this strong evidence of no active degradation. And we've got to ask ourselves, is my evidence strong enough to justify this? What are all the factors under those headings that I showed earlier? And finally, I think the use of technology in terms of non-invasive NDT technology, plant monitoring methods, and technology for analyzing databases, I think will in future provide an opportunity for better decisions to manage the risk and to lower the costs. So I will stop there and mute myself and hand back to Alan. But thank you very much for listening. And if you wish to contact me, I'm available on john.b.wintle@gmail.com, and I'd always be pleased to receive a question or a comment outside the scope of this meeting, because you never know what it could lead to. So many thanks for listening today. Thank you.
Good afternoon, everyone. Apologies for the technical difficulties. I think we're okay now, so we've reloaded the slides and we're ready for the second presentation. I do have the poll results on the first one, but just with time, I'll come back to those right at the end. So with this one, I'll introduce Dave Burgess. Dave is a colleague of mine from ABB, a principal consultant, extremely knowledgeable, and Dave will take us through non-intrusive inspection. Across to you, Dave, and please let's keep the time. Over to you, Dave.
Okay, thanks. Hello, everybody. My name's Dave Burgess. I'm ABB Inspection Technical Lead, so we provide inspection services around the UK, and my role is really to support the clients and the inspection engineers for ABB. Thank you very much, John, for that presentation earlier. You did very well considering the circumstances, and there's some things you mentioned. I'll follow up on that. Okay, so what I'm going to talk about today is non-intrusive inspection. Really about the approach, how you go about it, the guidance that's available, the technologies that you might use. So you can see the agenda there. What is it? What are the benefits, the limitations, the challenges? What methodology we should be using to make sure it's safe to do NII? And what assessment tools might be coming along to help us with that as well. And then a look at some of the technology that help us actually do the inspections in the field. Okay. So what is NII? Well, John touched on it really. So we have high hazard bits of kit on our sites, stored pressure energy, quite often flammable, corrosive hazards inside. And as a result, our UK regulations and other regulations around the world make it such that we have to undergo sort of statutory periodic inspection. And quite often that does involve non-destructive testing as well. And historically that's been internal visual inspection. But as John mentioned, non-intrusive inspection has appeared over time, and methodology is developed, and quite significantly there's been later methodology recently in the last year or so, so hence it's a good time to talk about what is the latest methodology in that. Now, NII can be with the equipment online or offline, so it might mean that it needs to be offline because it's hot and difficult to approach, but you still might not need to go in it invasively. So that's the point there. I think it's important, first of all, to understand why you want to do NII. What is your objective? And that can make a difference with your approach to the assessment and how you might then approach the inspection. Some people might want to do it to save money, but really the main points of NII are certainly above that, really. It's about, some good reasons there. If you've got equipment and you've got a large event and you want to understand the condition of equipment because you might anticipate repair, then it's useful to do that before the event so that you can identify any repairs up front in anticipation for a shutdown. It might be that you have so many items in the shutdown, then the shutdown would be unreasonably long, so you might choose the suitable candidates of vessels to do NII on, as providing it's safe to do so. It might be that you've got deferment postponement of a vessel coming up. Again, you don't have enough information or confidence in postponing it for the period you might want to. So NII is quite a useful process to help support a postponement. Another one might be to complement an internal inspection regime. So you might say, well, okay, we're looking at it between periods, but in between the invasive inspections, we'd like to do some NDT, and in a way that can be termed NII as well. And also, if you have upset conditions, maybe a pH excursion, that can also warrant you to say maybe not shut the plant down, but let's do some NII to see what the effect is of that excursion. Any of that, however, really should be defined such that the risk levels are not increased. And this effectively means that there should not be an increase in the probability of failure when you introduce NII. Okay, so thinking about the benefits of NII, I touched on it before. There's an obvious one, cost saving. You don't have to open up, isolate, prepare, clean, and all of that. Obviously, that will give you also increased plant uptime in not having to bring the plant off in certain circumstances. One other good reason that's cited is confined space entry, people going in vessels, the hierarchy of avoid and remove the risk then. But you've got to balance that risk, really, making sure, obviously, that if you're doing an NII, then you've got to make sure that you've not made the risk higher. You can reduce environmental impacts, the cleaning and disposal of emissions and odours. That can be an effect. But also, some vessels might not really, it might not be good for them to have disturbances, pressure, temperature cycles. So it might be an advantageous thing to keep the equipment in service as much as possible to avoid any form of disturbances in that way. And also, actually, it can avoid damage to internal components. You might have expensive catalysts in there, coating, refractory lining. So again, that might be a benefit of NAI. So there are plenty of benefits there from that. Limitations. Well, what would it be that would stop you doing NI? Well, if you don't understand the operating regime and there's potential for corrosion and deterioration, then you really shouldn't be going in that direction. If you don't understand the damage mechanisms, if you're not sure, if they're unpredictable, again, it's probably not a good idea to do NII. If you have high degradation rates, high corrosion rates, again, perhaps not a candidate for non-intrusive inspection. If you don't have sufficient inspection history or items of similar duty, then it's quite difficult to predict the damage mechanisms that are likely to occur and hence how you're going to monitor those. So again, maybe not a candidate. Where the item is close to end of life, John talked about that in his asset life curve there, then again can be unpredictable, so maybe not a candidate there. And where damage mechanisms can't be detected, or maybe there's extensive defects, manufacturing defects, or the obvious ones like national regulations might not allow it in certain countries. And the final one I think is also very important, is there's such a high consequence of failure, then maybe that's too much of a risk that maybe invasive inspection is the way you need to go. There has been some reluctance to NII. Really, traditional culture was it was invasive inspection, and it has taken a while for people to accept and adopt that. Some items are not suitable. It's very hard to inspect key aspects because of their certain design. Sometimes, quite often you turn around, something's open for cleaning anyway. So if it's open for cleaning, then why wouldn't you do an invasive inspection? Or again, if you're not sure about the damage mechanisms, then you need to have some confidence in that. It might be that there are some corporate rules that they're not, within the corporate organisation, they're not prepared to accept potentially a higher risk. So they might say, well, we don't want to adopt that. And sometimes actually, to support non-invasive inspection, it does involve quite a bit of technical assessment and NDT. And it might be that the cost of that might outweigh the benefit of what you might be looking for there. So on to the methodology. The accepted methodology, certainly in the UK, but I think around the world, is this one originally introduced in 2007, DMV RPG 103. And that's been developed over the years, and the latest version now was introduced in 2020. And that now provides a more quantitative approach. It's a 6-stage approach. And you can see the diagram on the right there for that. It involves an integrity review, then your decision process, then a planning process, then actually doing the inspection, and then evaluating and assessing the inspection results on the back of that. Looking at the integrity review, well, that's in a way what you need to do is gather all the information about the equipment. What's its history? Has it got damage already? An RBI approach is quite good. If you've already got an RBI, that provides a lot of that information. The very important thing is to do the corrosion and risk assessment, identify the damage mechanisms, and then, of course, you need to understand its operational regime and its operational experience. such that you can understand what might be the damage mechanisms that are likely to occur. So that's your integrity review. And then what you do is you go into this decision process, which is a two-stage process. The first part is screening. And you use the flow chart on the right to ask yourself the questions: is the vessel intrinsically suitable for non-invasive? That means if it's got damage mechanisms, you would want to use NDT to measure from the outside. And if the construction of the vessel won't allow that, then it's not intrinsically suitable. Has a vessel previously been inspected before? And is that still relevant? Or is there any other equipment on the same duty you can take credit for? So if you haven't got any of that, then it's very hard to make the case for an II. Is there operating history relevant? Do you understand that? And is that reliable? And then finally, if entry is scheduled for another reason, then that might say, well, do the inspection anyway. So if after that assessment it's saying NII is acceptable, then you go on to this other decision flow chart that asks for 3 questions. In that, what is your confidence and ability to predict the type and locations of degradation? Because of course, what you're going to be doing is doing an inspection from the outside, so you need to know what type of degradation to look for and where to look for it. So that's very important. And then, what was your previous inspection's effectiveness? So when you've looked at it before, did you look thoroughly? Did you understand what the damage mechanisms were and where they were? If you didn't have a good, reliable inspection previously, well, then maybe again that's going to make it difficult to justify the NII. And then the severity and rate of degradation. And if that's high, again, that might affect the decision. But if all of those are acceptable against that chart, then it allows you to go forward and do an inspection plan for non-intrusive inspection. So when you do that, what you need to do is define vessel zones where there might be corrosion or not. You can see the image on the right. So you get the liquid zone, and then you get the vapor zone, and you get the gaseous zone. And then you will look at the degradation types, and then you will develop an inspection plan. And that will be based on many things like the consequence of failure, the probability of detection, the confidence to predict the locations. So within the guide, there are many tables that you put figures into, and that will essentially give you the locations and the coverage required for the inspection. And then you will select the inspection testing methods for that, again, with the guidance within 103. And so that's the assessment. So you've now got the assessment plan if it's okay for non-invasive inspection. The next bit, item 4, is to do the inspection and make sure that it's done as per the plan. And then after the inspection, evaluate the results, because it doesn't always go to plan. You might not get the coverage you want, you might not get the results that you expect. So there is that final part of the evaluation to say, well, have we got enough information therefore to be acceptable? Okay, so that's in a way your methodology. On to now some assessment tools. Some organisations are now starting to sort of offer software tools, quite good. There's 3D model where you can actually display, helps you visualise the corrosion zones and actually overlay the NDT results on it. You can see the image on the right, and it guides you through the assessment process. So look out for those if you want to use those, and it manages all the information. There's lots of information data as well, which it helps you manage that as well. And but it is about like RBI software, rubbish in, rubbish out. You do have to have competent and experienced people doing the assessments. It's not just about the software tool. A slide here about challenges of adoption. Really, the point of this really is it's, the methodology, the latest methodology is relatively new. There has been non-invasive inspection sort of informally before the methodology came, and it was utilised successfully. And when you do these assessments, that costs time and resource in both the assessment side of it and in the engagement of advanced NDT. So I think we do need to have an understanding of what the expectations are in terms of compliance with the new guidance, because it can be quite comprehensive. It is a bit of a step change. Could there be exemptions for low risk cases? And I see it a bit similar. Some of you might remember in MUL 159 tank inspections, very good guidance for hazardous duty and many tanks, but maybe not for all tanks. And is the latest methodology the same? Moving on. Some NDT techniques here. I'll just skip through. Corrosion mapping, a very common one. This uses ultrasonics phased array, where it gives multiple scans, and it's all automated on a carriage that you can attach to the item, and it will scan and detect and map the thickness and give it you in a nice display. It's repeatable, so you can compare it with previous inspections. You can work out the corrosion rates or something, and things like that. So corrosion mapping, very good and very reliable and quite developed now. Another one, if your equipment's hot, the normal UT testing might be around about 60-80 degrees as a maximum. But there is special equipment where you can use ultrasonic thickness testing for up to 350 degrees. Special couplant, special transport systems and such. But again, advancing technology is allowing that to take place. Another one would be time of flight diffraction. Again, been around for a while now. This will measure thickness, but it's also very good for flaws, crack type defects. It's ultrasonic method again. It's like a pitch and catch method. You can see the image on the right where one transducer sends it and the other catches it. And it's very accurate and reliable in terms of measuring defects. So again, a common one that you might use for non-invasive inspection. Other digital inspection testing techniques, online monitoring, real-time corrosion erosion monitoring, again, wireless UT thickness gauges, and then more recently, robotic tank floor inspections. There was a webinar, IMechE webinar, or a new webinar last week on that, which was very good. So technology is advancing and allowing these non-invasive inspections. And then drones, we've seen those. Okay, they're not quantitative, but they're quite good at being able to recognise where there is damage, of which then helps you locate that, and you can then perhaps measure that from the outside if you think you can. So again, drones are quite good technology. And then moving on again, so in terms of technology, it's a moving target. I think we're all seeing that now. It's advancing all the time. You can see there, item one was visual inspection, and then we inspection and testing, and then we sort of did RBI and NII, and now we're moving into really these advanced techniques that we're starting to see that are helping us give more information, more reliable information. I think, like John said, he said that these still have to be tested to make sure that they are viable and reliable techniques. And like the ones that we are seeing now in terms of phased array and time of flight, they take a while to get the confidence, but they develop and we do have the confidence in them ultimately. A short case study graph here, in that 3 types of cases: onshore refinery, offshore platforms, and onshore and offshore. And you can see that percentage of items that might be suitable for NII. Remember that screening that we talked about earlier. So it's surprising actually once you go through the initial screening, you can get quite high percentages that could be candidates for NII. And some people have a belief that could be larger as technology develops. Okay, so in summary, non-intrusive inspection is becoming increasingly more the norm as the advancing of technology and methodology helps us determine that to be risk acceptable. They must be carried out, though, any assessments must be carried out by competent and experienced people. It's not just about the software, it's not just about the NDT. I think there does need to be an element of competence and experience there. In some cases, it's just not possible, or, well, it's not the right thing to do, due to the risk involved. And sometimes it's not possible because the countries, there are national rules and regulations that won't yet allow that. The inspection obviously will still be required if the NII criteria is not met, and I would say for very, very high consequences is that what perhaps you do need an element of invasive inspection to support NII. Okay, so that's the end of my presentation. I'm sorry it was quite quick, but we were aware of time, so I wanted to try and catch up on time. Okay, thank you all. We're back over to Alan.
Yeah, Dave, that was brilliant. Thanks very much for helping us catch up a bit on time. And apologies to the delegates, we didn't do the poll questions just to make sure we didn't overrun and we left some time for questions at the end as well. So with that, I'd like to hand over to our third speaker, David Glass. David is the mechanical team leader in the UK Health and Safety Executive. Across to you, David, and asset integrity in the process industry is the current issues.
Thank you, and hopefully everyone can hear us. And sorry, I'll gallop through this as best as possible, try and address some of the issues that have come up and add the regulator complexion to that as well. For those who don't know me, team leader, mechanical engineering by profession, team leader in HSE within the chemicals, explosives and microbiological hazards division. It's a bit of a mouthful. Basically onshore major hazards is what we're after. And we have a team of 15 or 16 or so of mechanical engineers who go with other discipline colleagues to high hazard sites throughout the UK, mainly on inspections, but also with some investigations as well. And I'll come to that and touch on it very briefly. In terms of what I want to talk around today, touch on a few things that have come up, a few future trends as well, and maybe very briefly touch on those. There's a lot being said about high hazards and the impact of COVID. I'll put a complexion on that. Touch on the issues with non-invasive, which have been probably the centre of attention today. And then a few issues that I'd like to bring up with a resolved case, a few emerging issues, and perhaps one or two trends that we'd like to highlight that we'd like to cease really, if we can. So without further ado, HSE has around 2,400 employees, and the mantra is we're dedicated to the prevention of work-related death, injury and ill health. It's kind of a hierarchy of our interventions, if you like, and we'd very much like to work on the advice basis. In terms of the hazardous industries arena, we will also undertake some assessment, some inspection, some investigation. And if things go really badly wrong, well, we're into enforcement territory and subsequent legal action. So that's HSE in a nutshell. In terms of HSE going forward, we publish reports every year and a business plan. We publish documents related to science, for example, as well. And throughout that, and persistently, has been this commitment to focus on high hazards. It remains a central tenet of HSE's business. And we're very much focused on preventing catastrophe. But in there, we also recognise that the world of work is indeed evolving. We don't stand still. Technology moves on. So we have to accommodate that, and I think it's right that we do. We're also mindful, I guess, that the arena of high hazards is changing. We have a diminishing reliance on fossil fuels. That brings with it some challenges. We have the advent of some alternatives as well. Hydrogen has been mentioned, CO2 planes, which may present different challenges to those that we have now. And we also have the advances in technology. We've touched on a few of the NDT ones today. We have changes in materials, for example. I'm keen to get some insight on additive manufacturing, for example, that a lot of you know. The digital twins philosophy is now beginning to enter our arena as well. So we need to get a handle on that. But one thing I think to bear in mind is the hazard remains high. We inspect these things. We want to keep the genie in the bottle. And the central theme running through the control of major accident hazard regulations really is that you should seek improvement. Stagnation is kind of acceptable, but what we won't accept is a decline in any of these risk management. We have to move on and get better. This is where perhaps some of the technology may help us. In terms of COVID and the impact, we've seen a bit of a significant jump. I think it's been alluded to in some of the presentations so far. This is some data that we've captured centrally, and it kind of displays the step change that we saw. The numbers associated with PSSR, or the pressure systems, where postponements have to be notified to us, changed dramatically in April of last year. And so as lockdown approached and lockdown took effect, we saw effectively hundreds of these things happen. Some of these are individual sites with lots of postponements, so bear that in mind. But in effect, in April of 2020, we saw more postponements in that month than we did in the entirety of 2019. So that gives you some kind of clue as to how the industry reacted. And these are purely, I should say, high hazard sites as well. So that also, I guess, points to some of the challenges that we face. So a big chunk of that is not shown. That's PSSR equipment. Bear in mind, there's a lot of what would some people may term non-statutory equipment, but the law still requires you to inspect it, such as tanks, pipework, etc. Some sites had postponement in place pre-pandemic already, and that presented something of a challenge. There are a lot of new or relatively new owners in this arena as well, people buying up assets and running them for the first time. They face some unexpected challenges too. It's very important to remember that the COVID pause changed the outlook for lots of people. Some people had inventory that they couldn't move, and so ran at high levels. Some people suffered some stagnation because of that. Some people ran empty. Some people partially decommissioned. So there are lots of differing threats, and they should be taken account of in any integrity assessment. And as has been alluded to already, some have adopted a non-invasive approach, partially to get them over the hump, if you like, for want of a better phrase. But there are changes in maintenance processes as well. And we're a bit nervous about an increase in what I would term temporary repairs, really defined life repairs, clamps, composite wraps, etc. Bit mindful of those may have increased in popularity as well. And I guess in accordance with our suggestion and suggestions that we put on our website, people have undertaken some risk assessments to keep running, including their non-PSSR equipment. We did have some significant findings from there, and have in some cases resorted to enforcement. So bear in mind, we will do that if necessary. In terms of how we move on from COVID, we've published a document which suggests that we really want to return to normal. In order to understand the impact, myself and the mechanical engineering colleagues, along with the regulatory colleagues, may well knock on your door, or as part of an intervention, if you're part of the COMA regime, knock on your door and ask you about the COVID impact, what you were doing before that, what you were doing during that, and how it affected you, what backlog you've left the pandemic scenario with, and how you propose to get back to normal. And we'll ask for some numbers around that if we can. It'll help us understand. One thing I should say about that, the COVID pandemic is, bear in mind this may not be the last one. We need a system that's resilient now, that factors all of these issues in, that we gain an insight into how it's impacted, but what else we can do, what systems we need to build to get around that. One other slight issue I might add, coincident with this, was Brexit. We might not sound that that's an issue, but things moving in and out of the UK, and especially Labour moving in and out of the UK for shutdowns, there's been some hint that may have been a problem as well. So I shall move on quickly and try and cover as much ground as possible. With respect to non-invasive inspection, a lot has been made in both John's presentation and the ABB presentation before that. The guidance is out there in terms of 103. We've supported that through its development over the years. Colleagues from offshore energy division supported that. We do have one or two issues with it, but that's the case with any evolving guidance, I guess. Bear in mind, it is guidance. You don't have to use it. And I think what we should be careful of is that we're outcome driven here, that we have an inspection regime that remains suitable all of the time. I appreciate the issue that it can be quite complex, but it's intended really for high hazard situations. So to my mind, the complexity and the rigor is appropriate. We shouldn't be entering into this without an understanding and a solid foundation of how your assets stand now. Your RBI schemes should be mature. They should be well managed. You should have a great understanding of the operating conditions of any piece of plant that you want to apply this to. And don't lose sight of what an intrusive visual inspection will gain you, because there's a lot to be said for it. There are some issues that I mentioned. My colleagues offshore have issues, for example, around Appendix C, first initial inspection. As has been mentioned previously, linings, for example, internal geometries can all cause very good reasons for not undertaking or not assuming a non-invasive inspection. And throughout this, please bear in mind you need to manage the risks to a log. It should be as low as reasonably practicable. One of the issues that we do have is this issue of confined space entry. We've had some duty holders come to us and compare the two. Fully appreciate that confined space entry should be avoided if at all possible. We get all of that. But the information gleaned from entering that confined space and intrusive inspection prevents a major accident. And we don't agree with the position that we should trade those risks against each other. The industry has shown over the years that it can manage confined space entry and manage it properly, which is very helpful. So please don't lose sight of and try not to use that argument. I have encountered duty holders who said to me, we want to move lock, stock and barrel, 100% of our inspection will be non-invasive moving forward. I don't agree with that in the slightest, and we'll fight that robustly where we come across it, because I think even as shown my ABB presentation, we can't move to 100%. That just doesn't seem practical. Certainly not for plants that was never built for a non-invasive regime. Maybe in the future we can get to that position, but I just don't see the population supporting that premise right now. With respect to moving on to other issues, I'll draw your attention to an instance which has now been through the court, and I'll talk around this really for the learning I think which came from it. This was a quite a scary instance. 17 tons of ethylene in 2017, a huge gas cloud, and I think this is a piece of learning for us mechanical engineers as well. 17 tons doesn't sound much, but my word, that's a very large gas cloud. They tend to be heavier than air. It finds areas of congestion. Thankfully, it did not find a source of ignition. But this is a major issue, and you can see that it even led to partially evacuation as well. In terms of the failure, and I can talk around this because we've been through the court system now. This is external chloride-induced stress corrosion cracking. The RBI failed to anticipate that and failed to recognise the full range of process temperatures, and hence it failed to recognise that this line could see significant periods of running at 80 degrees C. Very active chloride stress corrosion cracking there. And in terms of the source of the chloride, it's probably worth talking around that as well. This came from atmospheric chlorine as far as we're concerned. This is a coastal environment. It didn't leach from the insulation as far as we know. So bear all that in mind too, that your plant can be under threat from something as simple as humidity from a coastal environment. The other thing I'd like to point out is the failure mode. This is not a small leak. So this is a CUI failure that didn't result in a pinhole leak. Pinhole leak is bad enough, and a pinhole leak we would pursue you for anyway. This is a catastrophic failure. And we've seen this previously where damage coalesces in certain geometries and we will end up with complete rupture. We've seen a lot of assessments which suggest that, for example, CUI, this can't happen. Well, I think that it can actually, and we've seen this on a number of occasions. I recall going back to 2005, I believe, and the Corrosion refinery, long since gone, CUI failure there. Instantly, tens of tons lost and a fire that could be seen from Westminster. That was not a pinhole leak. So don't lose sight of the damage mechanisms and what might happen. Catastrophe is potentially just around the corner. One that I'm not, two instances which I'm not going to touch on greatly, but I want to put something out there because there's a significant learning here in both of these and challenges for operators who use NDT companies and operators who use third parties to come in and do some work for them. Firstly is an instance of radiograph duplication. This is on a significant scale. It's not one of the major hazard sites, but we have an interest in NDT and have pursued this. And it was a diligent third party that found this. The one thing I will say with this is we haven't had a hint at this before in a case in 2013 written to one of the NDT companies. This newer one is on an altogether bigger scale and is somewhat driven by various different motives. What I will say is if you're an operator or an end party user, or an end user of NDT companies, we put a lot of stock in the rigor and the honesty of NDT. And I think we all go to bed at night thinking that what we've seen is actually accurate. This instance showed to me that that might not well be the case and you can be cheating. In terms of radiography, we were lucky in that somebody found it. We were also lucky that there's evidence left behind. Someone undertaking UT, MPI, whatever it may be, they could readily cheat. And I think we're going to reinforce how much trust we put in NDT companies, and we will be pursuing this case. The second one really comes down to a recent coma operator and asset, a flat bottom tank, significant age, moving towards supposedly RBI, but without really thinking about what we can and can't get to. How we're going to check things like underfloor. CUI threat played down far too much. And I think an issue for me is also some features that plainly didn't exist and were then examined. We have some significant issues plainly with that third party, and we'll be taking that up with them, to say the least. So I'll not say too much more about those because those are ongoing. As has previously been said, in all of these systems, we undertake RBI, undertake non-invasive, are built on the top of RBI, and then perhaps move to a digital twin. It's all going to be meaningless if we put garbage into that system. We have to have a robust foundation for any of these inspection regimes that we undertake. We've seen a lot of instances that things like RBI lead to a lesser inspection, and companies are selling on that basis. Non-invasive inspection means that you can save a lot of money. Okay, that may be the case. But please don't enter into a dialogue about non-invasive inspection thinking that that's what you're going to alight on. It might not be appropriate for you. Don't enter into these regimes with a predetermined outcome, because that's just downright dangerous. And out of all of this, we really, really need some intelligent customers at the end of it, be able to interrogate and push back against poor assumptions. And the independence, as I pointed to in these cases, the independence and rigor is absolutely vital. Given that this was an IMechE webinar, I thought it appropriate to point to the MIT Code of Conduct with respect to how we all behave in these instances, and we have to be honest with each other. And even by potentially contravening regulation by act of omission would contradict the Code of Conduct. It's important that we're honest and rigorous in our job, and I thought I would point to that. In terms of the law, we can indeed pursue companies and individuals if we have to, if we find this kind of thing. So bear in mind that people undertaking inspections for somebody else, you do have a duty of care under the Health and Safety at Work Act. But it's also notable that if someone intentionally makes a false entry, if you falsely make an NDT report, potentially you are at risk. That's an offence under the Health and Safety at Work Act too. So that applies to lots of different people. I've battered through that in a raging hurry, mindful of the time. I hope it was informative. I hope I've at least touched on some of the questions that went before, and I'll hand back to Alan.
Thank you, David, and thanks everyone. So if we've got any questions, can I ask the delegates to fire any questions into the questions and answers? We've got 4 questions up there at the moment, but any other questions, please fire it in there. What I'll do while I wait for new questions to come in, let me go and look at the questions we've got. All right, I'll ask the first one to either well, let me start with Paul. The question is what kind of tools can be used to monitor, analyze the aging of an equipment? Sorry, John.
Okay. Right. Okay. Hope you can hear me. What kind of tools can be used to monitor the aging? Well, it depends what kind of aging that you are looking to monitor. And I think that Dave, in his presentation, highlighted quite a number of tools that can be used non-invasively, like time-of-flight diffraction, corrosion mapping, and things like that. I think that one of the things I didn't bring out, and I think Dave did, and I think it's useful to highlight this this halfway point of being able to enter vessels or equipment remotely. This still may involve opening, which has disadvantages, but the use of drones, the use of endoscopes, and robotic devices on cameras on robotic devices to crawl around the inside, where the results can then be viewed on a screen outside the vessel, I think provides quite a lot of benefit, and is probably not being used as much as it could be. It avoids someone actually having to enter the vessel through a large manway. The size of opening that you may need may be quite relatively small, and I think that so long as you can tolerate in some instances you may not be able to tolerate the opening of an inert system, then I think this is I think there's a lot more tools of this kind that are now available. Maybe Dave would like to comment on that a bit further.
Go on, Dave.
Hi, John. Yes, it's really thinking about what are the deterioration mechanisms, understanding that really, and then applying the appropriate method to understand where it is. So it might be thermal aging like thermal creep. It might be fatigue from mechanical cycling. And so you might want to do a bit of, say, surface replication, which is like a fingerprint, if you will, of the structure of the material, and from that you can understand, where it is in its aging cycle. So really, I think that's really the trick with inspection. It is understand what those mechanisms are and make sure you apply the right technique for that, whether it's surface replication, whether it's the ultrasonic method, or like David said, let's not forget, invasive inspection tells you a heck of a lot really, and we mustn't forget the value of that. Yeah.
All right, thanks, David. Okay, next question. What about consideration of incurring mechanical damage as a result of opening a vessel in order to carry out the inspection? David Glass touched on that around the harm to people of going into vessels. I don't know if you want to mention anything on this, Dave Burgess, around, we do damage.
Yeah, I can touch on this. I mean, in my previous career before coming to ABB Inspection, I was an asset engineer looking after high hazard plant, and in some cases, if you've got, say, maybe for instance a lined vessel, you might say, well, actually, the act of opening that up, every time we do that for inspection, we damage it, by putting access in there, and so is that the right thing to do? So it is a consideration, and even if I'm not saying you shouldn't do invasive, because quite often with linings it's very hard to determine the condition without that. Well, what you've got to do is make sure that you do the inspection, but you also include in that inspection what damage might occur, and also plan to prevent that as well. Simple things like at the end of ladders or scaffolds, you put pads on, to stop point loads, and you control the entry. So I think it's about recognising what damage can occur, look to prevent it, and then make sure that you, before you box up, you check for any damage that may have occurred.
Okay. All right. Thanks.
Mm-hmm.
Yeah, can I just come in there, Alan?
Yeah.
I just think that the precautions that need to be taken to avoid mechanical damage from invasive work and preparations, again, should not be underestimated, and particularly when vessels have got sensitive linings or internal structures, and of course there's always the risk that equipment, like a surgeon will leave, that the equipment might get left inside a vessel. It's almost as if one needs to sort of count what's taken in and count it out again. I don't know whether David Glass has got any examples of damage to vessels caused by inspection.
I think we have challenges along these lines quite often. For example, sulfuric acid, chlorine, lined vessels. I think we get that there is damage associated with, or the potential for damage associated with entry. That shouldn't stop us, though, understanding what the overall risk is. And I think, as you rightly pointed out in your presentation, John, catastrophic failure with chlorine vessels undetected would just not be acceptable. So okay, I accept as a balance there's a case to be made where damage may occur. That may be an instance where you can say we can undertake non-invasive inspection from the outside for the next round of inspection. But it also may be that you really then have to go back in a second time around. Each case is individual, and we are not excluding non-invasive inspection. On the contrary, we don't put people at risk. But what we don't want even more is a major accident.
David, it's Alan D'Ambrosia here. So in my past life, I was a turnaround manager, and obviously turnarounds involve a lot of invasive inspections, and and invasive inspections have a lot of preparation time, a lot of people on site. I guess in your view, do you look at also the sort of manning and the risks of putting a lot of people onto a site, onto an ethylene site or offshore, even worse, and we're trying to get a lot of multi-level work in, including going inside vessels?
I don't, as a mechanical engineer. I'll turn around and say now that I'm interested in the mechanical integrity and whatever it takes. And if that means that the shutdown is longer and there are less people, so be it. If you can achieve the same results non-invasively on some of the assets, by all means, do so. Be prepared to make the demonstration. But in terms of mechanical integrity, we can't accept anything less than where we are now. We would really like to see, ideally, even better assurance.
Yeah. Okay. All right. Next question. Back to. Let me choose. How frequently should results of an RBI be reviewed? I'll ask that first to Dave, and then I'll ask it to David, and you see if we get the same answer. Dave, you go first.
Yeah. We get this question a lot. We get this question a lot, actually, and I think the ideal and best situation is after every major inspection, every thorough inspection. That really is the best practice, because that's when you get your information from the inspection. That's when you can feed that back in terms of things like corrosion rates, anything additional seen, any improvements seen, and so on. So that would be the optimum. I think if you're talking about a timeline, some people might go longer than that. Whether you want to put 10 years on that or not, I don't know, but really the ideal is every thorough inspection.
Okay, and
John, do you want to comment?
What I would add to that is that not only do the results of inspections need to be reviewed, but also a reflection on how the plant has been operating during that period since the last inspection. Have there been any excursions? How many cycles has it received? Are the results from what we are seeing from the inspection consistent with our knowledge or our believed knowledge of the state of the operation of the plant? So there's two sides: the inspection results, but also the plant data and operating records.
Yeah. And David, do you want to give what the HSC's expectation would be?
In some respects, there's not a right answer to this. I don't mean to sound evasive there, but what I would say is this. For example, British systems regulations suggest or require that your written scheme remains suitable and sufficient at all times. It also requires periodic review, and as has been alluded to, the best time to do that would be after each thorough examination, because you have contemporary information, and then ask yourself, does that scheme remain appropriate? And that's also exactly the same for pipework, tanks, etc. In terms of a formal RBI review, again, I guess it comes down to when it's appropriate, perhaps every 5 years, because as John has rightly pointed out, there are other aspects that we do have to feature in here. If you change a supplier and suddenly find yourself with a slightly more aggressive cocktail, for example, for process conditions change, all of these things need to be factored in, and you need a backstop to catch them. Ideally, a management of change process catches all of that, but a backstop is required, and a formal institution of an RBI review program would be appropriate. At a frequency is to be determined.
Okay. All right. And next one for yourself, John, is how do you determine the inspection frequency for a vessel that has just been deployed into service?
I think it's a very, very good question, and I think it boils down to is not so much the frequency at that point when the vessel is about to enter service, but at what point of operation does one want to carry out the first thorough inspection. And this first thorough inspection would, unless there were overriding considerations otherwise, be an internal examination. And I think the answer to that question is depends so much on the particular process and the context of and there will often be operational considerations where the plant is run for a period of time, possibly a couple of years, maybe longer, before things I think that first thorough review needs to take those factors into account. Of course, there may well be in that early life some commissioning issues, some little operational niggles, and it may be that the plant has to be taken down after a relatively short interval to address these. And at this point, it may well be an opportunity to undertake your first thorough examination to see what effect the process is having. I think one would be very surprised if there's anything found, but you just never know and doing that gives enormous assurance that it's behaving as you would expect on the basis of how it's been designed and planned. It's the best answer I can give. I know it's not people want a date. I can't do that, but I think those would be the factors in my mind.
Okay, thanks, John. Another question for David Glass. So, in the case of the chloride-induced stress corrosion cracking, the external pipe did not appear to be corroded from the photos. Was the crack internal? Was there a general thinning that led to such a large leak? Correct material grade? ?
It was externally driven, so it's not to do with the process fluid. This is very much to do with the environment, and it was, I guess, multiple cracks which coalesced in the direction that you would expect given the load on a pipe. The water more than likely hung together on the underside, so it was the underside of the pipe, 6 o'clock. The chlorides began to leach through pretty much along a 10-inch length, and it was that fracture in the middle of a run which caused the leak, and it let go catastrophically. So it's not wholly unusual. It has happened before, and it's one that people, and I was keen to put it up for the very reason of the morphology of damage. People need to understand it, and it can happen.
I think that's a really good example, David, of a pipe which of a scenario that one might not easily foresee. Possibly, it may well be as a result of condensation or simply rainwater or deluge water falling on a pipe. I don't know quite what its context was, but somehow whatever was happening, that water didn't all fall off, and rather like a sort of a stalactite, it a little bit remained underneath and concentrated and chloride was sufficiently concentrated to then initiate the crack. I did think when I looked at it, it could have been a welded pipe, but I don't think it probably was. So I think there is an instance of condensation or rainwater collecting at the bottom of the pipe. Is that what we're saying, David?
Pretty much moisture. We have the concentration up, as you say, of chlorides. The insulation holds it in position on the underside, as you might imagine. So this is a horizontal run of pipe, and the conditions that the pipe saw changed, but certainly weren't anticipated in the RBI. The RBI anticipated something altogether colder outside of the SCC range, but unfortunately, it was inside for at least part of its life.
But there's an example of how a change in process conditions led to a degradation mechanism that was not expected.
Well, I think it's important to point out in this case that the conditions were correct. The design assumption in the RBI, fed into the RBI, wasn't correct. The pipe in this case and that loop operated as anticipated. It just wasn't fed into the RBI properly.
Right. Okay.
Okay. Right. Last question, I think. I'm not sure there's an answer to this. What are the tools and techniques that can be used to balance the risks from COVID, NII, and aging plants? I'll start with Dave Burgess because we haven't heard from Dave for a while. Then I'll go through the other two. And Dave, what have you got up your sleeve to balance COVID, NII, and aging plants?
Yeah, it's quite interesting. We've obviously the HSE and UCAS guidance during COVID was the expectation was to carry out doing inspections during the pandemic, but obviously with all of the controls and risk assessments that we're all very familiar with now, and we have done that. But there was quite an element of postponements. And ensuring that those postponements were, thoroughly reviewed and to make sure that it was safe to do so. So that's certainly one of the tools and techniques that did that. I'm not really sure there was a great deal we did different other than that. I think at the end of the day, we still did the inspection to the written scheme of examination. It just perhaps took a little bit longer. And to get through it really. Certainly things like with NI we've talked about the tools and techniques for that. An aging plant, I think it's very important to recognise the potential for aging, whether that be cyclic conditions or thermal conditions or just plain old corrosion. And it's not just about its sort of numerical age, it's about where it is in its cycle that John is really an understanding where you are with that. And again, we see and challenge that and look to understand where that is for the equipment we inspect.
Okay, John?
Yeah, I think this is a really great question because it widens the debate into reality, where one is faced with coincident and to some extent competing risks and risk mitigations. If you have a threat from aging, you may address that by invasive inspection, but that then may put up the that then may put up the risk of catching the virus. So I think the principles really are first in trying to balance this out is first of all to reducing the risks for as low as reasonably practicable. And my risks there is the total risks of the situation, which might be the COVID risks, it might be the aging risks, it might be the invasive or the risks incurred in undertaking NDT. And so I think a holistic approach, looking at that total risks picture and asking, have all these been reduced as low as reasonably practical? And then I think there's a further test, which is considering what is the residual risk when we've reduced the individual ones to as low as reasonably practical. Is the residual risk still sufficiently low for us to continue? Are there any risks above which we feel uncomfortable and would feel that a line has been crossed? And I think there are certain points, and it is and it's companies and individuals will need to judge where that line is. So I think it's a really good question, and because life is comprised of multiple and competing and coincident risks.
Okay, and David Glass, if you remember the question, so it's to balance what are the tools, techniques that can be used to balance the risk from COVID, NII, and aging plants?
I think it's important to point out that each one of those is a discrete risk that has to be managed and has separate outcomes and separate considerations. If, for example, that it's not appropriate to put 3 or 4 people inside a vessel at once because of COVID, and we have to do it serially to get the same mechanical integrity assurance, well, that's what has to happen. We can't then say, well, we'll trade COVID against the integrity risk. So that's my view, and I think that would be your colleague's view. Each one's an individual risk that has to be managed to as low as reasonably practicable. And unfortunately, sometimes that just means it gets pretty awkward. And we also know how awkward COVID has got.
Yeah. Okay. One last very quick question for you, David Glass. Someone was asking what material was the ethylene pipe fabricated from, please?
From recollection, well, it was certainly a 3 series stainless steel. My recollection is it was 304, but I couldn't swear to that. It's not my case, I'm afraid. But
okay. And it's the same person asking, is there a report of the findings of this? He's mentioned the company, so I'm not going to mention the company. But is there a report with the findings?
There isn't. And it's a moot point, to be honest. I think it's a contention internally that I've had for quite a long time that we used to do this. We used to put notes out about the failings, the findings for learning purposes, and we seem to have ceased to do that, with the exception of the Pembroke accident not long ago. Personally, I would much rather serve the industry by doing that. If someone wants to petition HSE senior management to do that, please do so.
Okay. All right. Okay. I think that's the last question. We've overrun. So can I thank the 3 speakers? I think the 3 presentations were all excellent. Very interesting. A huge sort of building up of the themes across the 3 presentations and so on. Apologies right at the outset with some of the technology issues we had. Hopefully that didn't change the flow and so on. And thanks everyone for sticking with us for the last 2 hours into this. And please, we've got the next we've got the next IMechE Tech Talk on the 9th of June around heat exchangers and energy savings in heat exchangers. And it'd be great to see as many people come along to that as we have had this afternoon. Thanks everyone, and I hope you all have a lovely evening and a safe evening.